Welcome all of you to this lecture, and therefore today our focus is how one should look at the growth. So the debate is for prosperity, one of the most important indicators is economic output, and here is the Y, and then the rate of changes in the output, and that is growth. So there are various classical models are there for growth estimations, and also we also know that there are various components which are attached to growth calculations. So we will be talking about two basic models which are very simple, but yet is like one of the points of the departure in the growth. So we will begin with the famous economic growth model, what we call Harrod Domar growth model. Roy Harrod and F.C. Domar independently they developed theories on the economics rate of the growth, and its connection to the capital stock, and both of them are we're talking about the same, the connection between economic output and also the capital stock. And also this Harrod Domar model also is seen as a neo-Keynesian model. All of us, we know that John Maynard Keynes emphasized the impact of investment on aggregate demand, and aggregate demand we'll discuss much more in details when we will be talking about elements of macroeconomics in our ensuing lectures, and there we'll talk much more in detail like aggregate demand and aggregate supply. But as of now, we know that impact of investment on aggregate demand was emphasized by Keynes. Harrod Domar emphasized how investment spending also increased an economy's productive capacity. So basically this is the supply side effects they emphasized on. So there are basic assumptions in the Harrod Domar model. So and from the model itself, from the assumption also itself, you will be able to know is very simple, but then is very very powerful, and is very widely recommended and also widely used in developed countries as well as developing countries. So let us see what are the basic assumptions for Harrod Domar model. So it emphasized on the investment on economy's productive capacity, and this is what we are talking about, supply side effect. And also within the Harrod Domar framework, the growth of real GDP, and GDP here is Y in our closed economy equation, is assumed to be proportional to the share of the investment. So as investment increases, and then simple assumption is that Y is also increasing, like that's how Y and I are related. And for an economy to grow, net addition to the capital stock are required, like from the investment capital will be generated, and that's how the accumulation process that Harrod Domar emphasized on. The third assumption is this model assumes an exogenous rate of labor force growth. So here is it is not impacting in the model, but then labor force growth, if we consider N as a proxy for the total population, and N is the total labor force engaged in the economy, so then this is exogenously given in Harrod Domar model. Now moving to the fourth assumption, which talks about technology is given at a fixed factor proportion, which is considered as like K and L ratio, like capital to labor ratio is fixed. And then it is also assumed that capital and output ratio is also fixed, and it will grow at a fixed rate. We'll discuss this when we talk about the model, and this is considered as I said that it's a simple model, and therefore two sectors model here, only households and farms are are taken into consideration, and it is applied in the closed economy. So let us now move to Harrod Domar growth model. So it is precisely shows the relationship between economic growth and unemployment in the advanced capitalist society. I mean, that's how it started, and then it also focused on the role of capital accumulation. As I said, that investment is important factor for output growth, like Y, and then in the investment, capital accumulation process is very important for regenerating the net capital stock, because capital stock plays important role for output growth. Although it started applying in developed or advanced capitalist societies, but then it also widely used in developing nations, including we know that expenditure, if we follow the expenditure Y equals to C plus I plus G, but then total overall production function is like, as only two factors of productions are used from the household and are used in farm. That means in the economic circulations, only two factors of productions are used, that is capital and labor, and so it is, and we are keeping other things including technology constant as per the assumptions. So it is in this production functions, the equation 1, it shows that economic growth occurs by either by increasing the capital stock, like say through new investment in factories or machineries, equipment, roads and other infrastructure, or or by increasing the size of the total labor force of the nation, or maybe both. So this is how the production function in the Harrod Domar model is, like, in simple way it is there. So now if we go with the Harrod Domar, so here as we know that Y is equals to C plus I plus G, but Y also can be written as is a sum of consumptions and savings. So savings is basically the leftover after the consumption. So here that we can write this way, like Y, and here we are introducing small t. T is a time, like at any given point of time. So even Y is like output in, say, if we consider this is in today's time, so t is, say, t here equals to 2025, for instance. So yt is like output at time, like time t, which is a sum of consumption at t, and then also savings coming from that time period. So now it is just to remember, like YT here we are representing as gross domestic product, and then equilibrium conditions that we already know from our previous lecture, that in the Keynesian approach, like investment equals to savings, means savings needs to be invested. So savings like leftover after the consumption from the output, and then whatever the savings that household will be doing it either in the financial institutions or any other means, but then that savings needs to be invested in the farm. So that is why two sector model here. So this is one equation, equilibrium conditions. Saving function is like st is equals to small a's, and small a's is the rate of savings, and yt is like yt is equals to output. So that means savings is proportionately related to output at the rate of small a's, is like savings rate, like what is the propensity to save. Like small a's also can be referred as propensity to save, like how much, at what rate I'm saving from my say output, like whether it is 2% or 5% or 10% or 20%. So it depends. So that small a's is a saving rate, So now it is important to point out like capital accumulation conditions. So what would be the capital accumulation conditions? And here kt plus 1 kt plus 1 is like capital stock at t plus 1th time will be investment at t like it plus kt like initial capital stock at t, and also whatever the investment had happened, and then what capital stock from investment it has happened, and then delta is a depreciation on k, because k is the capital stock from investment, and therefore k is the investment on machineries and equipments and etc., and therefore it has depreciation. So depreciation will not be on the investment, depreciation will be on the capital stock. So and therefore for k capital stock at t plus 1 period, it will be investment at t, and then capital stock at t period, and then delta k t period, and which is getting subtracted. So now we can write this capital accumulation condition we can write as kt plus 1 plus it plus 1 minus delta kt. So this is like the process, capital accumulation process will happen this way. So this is equation for capital accumulation. This is very, very important because we will be using for next also, but then this is the one of the starting point for the Harrod Domar. Even those like say Solo, when Solo developed much more comprehensive growth model considering non-linear assumptions in the growth equations. So but then process capital accumulation conditions is used from this equation 4. So this is very important for us to remember. So this is one of the points on which all of you should be remembering. This is how capital accumulation happens, and then investment, initial investment, capital stock, and depreciation rate is important there. So now when we can rearrange, like how investment can rearrange. So from equation 4 we can actually write this way, kt, and then we are bringing this component, like last component of the equation on the right hand side of the equation 4, we are just bringing this equation on the in one side, and then investment is basically nothing, is a net net capital stock, like between two period, like period t plus 1 and t. The ratio, as we said, that capital output ratio is fixed and it grows at a fixed rate, one assumption of the Harrod Domar, and therefore small v is, let us assume this is capital output ratio. So if k is a capital stock and y is GDP, then k by y is the small v, is a ratio. So if and v is fixed, and therefore kt by yt will be equals to v, or kt plus 1 by yt plus 1 will be equals to v, because that's how this ratio is increasing. So if we are fixing at 2%, then for every year, like whether it is t or t plus 1 or t plus 2, this ratio will be will remain same, like at the rate of v, and therefore v is equals to kt by yt, kt plus 1 by yt plus 1, likewise kt plus n by yt plus n, but all will be equals to v, and that exactly it means, like it increases, that ratio increases at fixed proportion, like that is v. But then this one can also write like kt equals to vyt, just to rearranging, or kt plus 1 equals to vyt plus 1. It's just we are taking the ratio with respect to capital stock. Means capital stock, just like investment, capital stock will be increasing proportionately with the output at the rate of v. just like savings rate, like savings will be increasing with proportion to income, but at the rate of small a. Small a is the saving rate. So now with the same logic, incremental capital output ratio, one can also write is like small v equals to delta k by delta y. So this is the incremental capital output ratio. So now moving next, since k t equals to v y t and s is equals to I t, then we can write I equals to small s yt. Like we are just replacing the value of st, which is small s yt, in place of savings, and therefore using capital accumulation process, like from the equation 4a that we used, like here in place of I we are writing k t plus 1 minus a k t plus delta k t equals to small st, and then putting capital output ratio, like in place of k t plus 1, that means v y t plus 1 minus, in place of kt it will be v yt, as we know, like kt equals to v y t. So just we are using this one and we are putting this value, and then we get this one. So if we rearrange, like if we have v out of this, and then yt plus 1 is like minus yt plus delta v yt equals to yt. We are keeping all other things same, and then if we follow this, we get this equation again, and then if we rearrange everything, like y t plus 1 minus yt, and then we are bringing this y here plus this small s from here divided by v here. It just we are writing like v y t plus 1 minus just t by y t plus delta v y t equals to small s y t, small s, and here this is nothing, it's like we are keeping it this minus, and then yt will be equals to small by this v, and then this one will go on the right hand side, so minus delta, because this t and t here also, since we are bringing this yt here, so t and this then t will be cancelled out, and v will be cancelled out. So therefore and then we get this equation from here. So just those who will be having some difficulties in how we obtain, so it is just one step that we skipped in the equations, but then this is how we get it, and this is how the final equation 8 we get, and small g is nothing, it's like small g equals to this part is. So here one can actually consider like delta is depreciations. If depreciation doesn't happen, then delta will be equals to 0. Then in simple expression will be g equals to small a by v. So it is very clear that g is positively related or proportionately related to s, like one can write g proportionately related to small s and g disproportionately related to small v. Following income or expenditure, that is fine, but then in the growth, when we try to understand relative sense, like changes in the output, for that total savings doesn't matter. I mean, what matters is like savings rate, like at what rate savings is actually related to savings and the output, and small v is like incremental capital output ratio, at what rate capital stock is actually impacting on the output. So this is the Harrod Domar equation. So now interpretation is like here simple interpretation, like one can write like g equals to here d is like delta D or delta is represented as depreciation. So capital created by investment is the main determinant of the growth in the output, and saving makes investment possible, because we have to recollect in our one of the previous lectures, where we have shown how farms and households are interrelated, and then of course investment is the main factor for the farm to grow, but then investment will come from the household. So therefore household, how will they invest? So basically through savings. So savings will make investment possible, because from the equilibrium conditions where investment and savings they are equals to each other. And then two key factors takeaways from here is like savings rate and then productivity of the capital, like small v. I mean, that is what more important. And save more and make productive investment, economy will grow. So this is as I said, is a very simplistic model of the economic growth. And simple point is like you save more and then productive invest productive way and make good investment, and then economy will grow automatically. And then labor force, this assumption in the Harrod Domar they kept it very simple, but then at the later stage it was discussed like population growth cannot increase at the same proportion to the capital or output. So but for now, for Harrod Domar, we are just keeping it labor force, which is like will grow at the same pace as the population rate grows at the rate of small n. So small n we are not emphasizing here more, but then this will be taken later in the model. So now therefore one can write like G will be equals to n, like here at the rate of growth also will be will happen at the rate of population or labor force at the same labor force, that is n, and then small is by v, which is saving ratio of savings rate and capital output ratio, and then depreciation. So this is one can actually write this way. So now in our course in the economics of public policy, why in the policy Harrod Domar is important. Now let's take a one example of the policy. Like say this is economics of public policy, and here in the policy discussion let's take an example of say tax, and then tax is a source of the government revenue, and then that needs to be spent. So G and T are very important part of the fiscal policy. Let's take an example of say T, and then also we'll consider G, how G is. Suppose tax rate is capital T, because small t we already considered as the time, and therefore capital T we are keeping it as tax rate. And imposed on the disposable income means YD, we already discussed in our large grand macro equations. And then capital accumulation, then it will be like KT plus 1 minus KT plus delta KT. As I said, that 4A equation is important, because that is the equation of the capital accumulations. And then in that case on the savings we had small s YT, but here small s, like since savings function will be changing with the change of the income, and here income is we are considering disposable income, and here like small s and 1 minus t. So that is the functional relationship of the savings. Look, so now savings is t will be like this equation, right? So this is like savings now is not only proportionately related to YT, here it is like small s 1 minus t, because tax is imposed. So now with capital output ratio we can write like this way, like we are putting the value of KT plus 1, which is small v YT plus 1, and then KT is like small v YT plus delta YT VYT, and then S On the right hand side we are keeping the same. So this is equation 2, like capital accumulation equation can be written like this way, and growth equation one can write this way. So just we are rearranging, like here I think we don't need to explain further because we already discussed this. So of course this V we are taking it common and then placing them on the right hand side, and then we are just keeping growth here. Like growth here means y t plus 1 minus yt and then divided by yt from the right hand side. So that means yt plus 1 minus yt and then yt, and then from here small s, like s and then minus styt. But then since we are bringing t from the right hand side, then it will be small s, then v is coming from left hand side, and then it will be like small s by v minus again small s by v, and then t, and then minus like this minus delta is a depreciation. So now like what is the interpretations from economics growth point of view? Economic growth, as economic growth increases with the decreases with the increase of the tax rate, because here G will be G and T are negatively related, and income and growth will be increasing if tax is as tax decreases. So tax rate raise the reduce private savings and private investment declines, because tax is a tax will enact as a negative or demotivating factor for the private investment and private savings, because as tax increases then obviously disposable income will be less, and then after consumption leftover, which is savings, will be less, and therefore private savings, so that is actually private savings, and private savings will be less, will be reduced. And if private savings is less, then private investment will be less, and this will reduce the entire total capital accumulation in the long run growth. So this is how imposition of the tax, this is how economy will play if government intervention is not there. So private investment and savings will be discouraged. So now what happens? I mean, when we already know that in the budgetary policy, like in budgetary policy, once government receives the tax, means revenue, then obviously it needs to be spent, and that's how the G is government expenditure. Like it is not only about Y plus C plus I. In case of private expenditure, of course it is, but then the moment you bring G in the closed economy, then government expenditure also will be there, and this government expenditure is basically coming from T. So T is a source for the public expenditure. So but then T is a if T increases, then private savings and investment will be less, but then with the T as a revenue, as a form of revenue collection for the government needs to invest. So if private investment is declining, that does not mean that government investment will be declining as well, because government will have the tax and government will reinvest that through budgetary policy. So now if suppose lambda, we are taking one more coefficient, and that is lambda is the rate of public investment, like GT, and let GT is the beta rate of T. So capital accumulation can be written as like say, as I said, KT plus 1 minus KT plus delta KT. This is left hand side, we are keeping it like from the investment side it is coming here, plus since tax is already imposed, and then whatever the tax is imposed, that needs to be spent at the rate of delta by the government through government expenditure. So this is how. So now one more, so this one can rewrite the accumulation, capital accumulation process. This is how it will happen. Like tax will be imposed, but in return government will also spend. And then GT equals to means government expenditure is a proportional to the total Y. So it's not that G is independent. G and the tax collection also will not be independent. It's basically tax will be collected or revenue. I mean government expenditure will be there with the proportion with the proportion of the total output at the rate of beta. So here GT and YT, they are positively related. So equation 2. So now it can be written. So now we can rearrange everything, and then here we are placing the value of KT plus 1, because from the capital output ratio, like VYT plus 1 minus VYT plus delta VT. So we are keeping V common, and then here S is this S 1 minus T YT plus lambda. We are placing the value of GT as beta YT. So now all we can rearrange, we can write this way, and then I think we don't need to explain further how it we got it, because in our previous 2 slides we already expanded this how we are getting it. And then final growth equation will be like G equals to small s by v. So this is fine, just like this. But then here it is like lambda here is like the rate of public investment, beta is the rate of rate at which government will spend with proportion to the total output, and then depreciation is as it is, and v is our output, capital output ratio. So this is how one can actually expand the public investment and tax. Both are if both are functional, and then through fiscal policy, and this is how Harrod Domar growth model also will be changed. So I hope up to this is clear. So now this, as I right from the beginning, I am saying that this model is very simple and also draws a lot of criticism, and then the assumption on which, or the basis on which the model was criticized, but then the acceptance for this model is because of its simplistic form, which actually can give the functional relationship between output, then unemployment, capital stock, and then savings rate, and etc., and therefore on that basis it draws a lot of attentions positively. But then of course because it is too simple and it is too linear, and therefore it also draws a lot of criticism. And here inflexible technology is one of the reasons, and then capital labor ratio is fixed as a constant, and also k by y is fixed. And when we are saying K and L ratio is fixed, like K and L ratio is say fixed, say alpha, if it is fixed, then K and L must grow always at the same rate, and this is where the problem starts. It is not always possible in the dynamic model. And then labor force of course must grow at the same rate of the population growth, and therefore this is the equation that one can get, like small n equals to small g equals to small s by v, and if we are considering delta or say d equals to 0, like depreciation. But what happens if population growth increases or faster than g in the case of unemployment, rising the unemployment, or if n is less, increasing less at the less rate as compared to the growth, then of course as an outcome we get the capital stock, more capital stock. But then if this is the case, then also this unemployment also will be rising if population growth is rising faster than the growth, and this 2R is sort of problem, and therefore what we get is the knife edge problem, which actually states the instability of the economy, and it happens when small n is not equals to or G is not equals to, small a's by V ratio. So for this Harrod Domar model, I have used this reference like from Brain Snowdon and Howard Devane in their book. I used 2005 book. It's a modern macroeconomics, and chapter 11 will be helpful for you to follow Harrod Domar model. And I hope you enjoyed this lecture, and I'll see you in my next lecture. Till then, thank you.